Hello, let's take a look at complex numbers and solving equations with complex numbers. In this particular problem, we're going to work with the complex conjugate. So we see here that we have z plus 2z, and this little symbol here indicates that this is the conjugate is equal to 4i minus 1. I is the imaginary part of my complex number. So let's begin by saying that z, my complex number, I can write it as x plus iy. So I know that x represents the real part of my complex number, and this I times y is my imaginary part of my complex number. So the conjugate, if I'm going to indicate it here with a star, is going to be x minus iy. So I have my z and I have my z conjugate. So it's my complex number and the conjugate of my complex number. If I look at the equation given, they tell us the following. So it is x plus iy plus 2 multiplied with the conjugate, which is x minus iy. And this thing is equal to 4i minus 1. So what I want to do is I first want to rearrange the left hand side so that I have something that looks similar in the order of the right hand side. So if I want to expand the brackets, x plus 2x is going to become 3x and minus iy, because what I have here is I have iy positive, and here I have minus 2iy, so it becomes minus 1iy. And this is equal to, now I'm going to rearrange this to say that this is my real part plus my imaginary part. Now what I can do now is I can compare coefficients. So in this case here, if I compare the coefficient of x, I'm going to see that 3x is equal to minus 1. So I'm comparing my real parts here. And then x is going to be negative 1 over 3. Then if I compare my imaginary parts, minus iy is equal to 4i, then y is going to become minus 4. Of course, don't worry about the i's at the moment. I can ignore the I if I want to, just to solve for y. But now if I want to solve this, I have to give it in my form of a complex number. So z is equal to, and the real part of my complex number is minus 1 over 3, and my imaginary part is minus i4, or alternatively I can say 4i. It doesn't matter where I put the imaginary number. So alternatively, if I write this, it is also sufficient. So I have solved for z.